So we're still looking at solving rational equations in typical fashion. The process is the same, but the actual equations become a little bit more complicated as we move forward. Our first step is to factor any denominator that can be factored. So we're looking at this rational expression on the left-hand side of the equation that has x squared minus 7x plus 10. So we want to know what two numbers add to negative 7 and multiply to 10. What two numbers have a product of 10 and a sum of negative 7. So we'll write this down over here on the right-hand side of what we had. I've put a comma here. I'll make it a semicolon to be a little more formal. We have x plus 13, and then what two numbers multiply to 10 and add to negative 7? Well, we know it's going to be x and x, and we know it's going to be minus and minus because that's the only way to get a product that's positive and a sum that's negative. And if we have 2 and negative 5, that would multiply, or excuse me, negative 2 and negative 5, that would multiply to negative, or multiply to 10 and add to negative 7. So minus 2 and minus 5, and you can multiply back through if you want to verify. X squared minus 5x minus 2x is minus 7x, and then negative 2 times negative 5 is 10. And this is still going to equal 6 over x minus 5 minus 4 over x minus 2. And then we'll put a comma here, and what can x not equal? If we have x equals 2 or x equals 5, we'll have a denominator of 0 in one or more of the terms. So we know that x cannot equal 2 and x cannot equal 5. So now that we have the factor denominator of the left-hand side, we multiply both sides of the equation by the least common denominator. In this case, that's going to be x minus 2 times x minus 5. So we'll write down the left-hand side, x plus 13 over x minus 2 times x minus 5. That gets multiplied by x minus 2 times x minus 5. And then the right-hand side of the equation, we have 6 over x minus 5 minus 4 over x minus 2, and we're multiplying that all by x minus 2 times x minus 5. On the left-hand side, the denominator cancels because we're multiplying by the denominator, so we're left with x plus 13. On the right-hand side, when we distribute the x minus 2 times x minus 5, when we multiply that by the first term, the x minus 5's cancel, and we're left with 6 times x minus 2. And then when we multiply it, distribute it to the second term, we still have a minus here, and we're left with 4 times the x minus 2's cancel. So 4 times x minus 5. Distributing those values, on the right-hand side, we end up with x plus 13 equals 6x minus 12 minus 20, or minus 4x plus 20. That's from the 6 times x, 6 times negative 2. Negative 4 times x is minus 4x, and negative 4 times negative 5 is a positive 20. We'll combine like terms on the right-hand side to give us 6x minus 4x is 2x, minus 12 plus 20 is plus 8. And we'll go ahead and move everything to the left-hand side, or the variable terms to the left-hand side. So minus 2x. So the minus 2x's, or the 2x's will cancel. 2x minus 2x is 0, and x minus 2x is negative x. And then we'll go ahead and subtract 13 from both sides. So the 13's cancel on the left-hand side, and 8 minus 13 is negative 5. So dividing both sides by negative 1 gives us x equals 5. As always, we will check our solution by substituting into the original equation. So we have 5 plus 13 over 5 squared minus 7 times 5 plus 10. And we want to know, does that equal 6 over 5 minus 5? And if we look back here at our original statement of what x cannot equal, it's because with this first term on the right-hand side, we're going to end up with 6 over 0. And actually, if we multiply this out, 25 minus 35 is negative 10 plus 10. We'd end up with 18 over 0 on this left-hand side. So x can't equal 5, which means there is no real solution. And this demonstrates that if we didn't recognize or remember that we had x doesn't equal or can't equal 5, it will show up in the check. When we substitute, we'll end up with a denominator of 0, one or more denominators of 0, and therefore there is no real solution.